So we're going to go more in depth in terms of our inverses, but we got to think about where we're standing when we're looking at our inverses. We know that when we have sine, if I look on my xy plane, where are the two quadrants in which sine is positive? So in here, the sine is a positive, and over here, the sine is the positive. So if I asked you for the sine inverse, do you all remember what inverse means from pre-calc 1? Does anyone need a quick refresher on inverse? Yes? Okay. So let's talk a little bit about inverses. If I give you this function f of x is equal to 2x plus 1, that's the function. If I asked you to put in, say, 3 into that function, you have 2 times 3 plus 1, and so you get 7, right? What if I have the answer? What if I tell you that f of x is equal to 10, and I wanted to know what I put in there? The way in which I do that is I would do the inverse of it. So the inverse of it, I would have said, I've got y is equal to 2x plus 1, and now I'm going to solve for x. So I'm going to take my y value minus 1, divide it by 2, and that's what my x is. Notationally, what we would have said is f inverse of x is equal to x minus 1 divided by 2. When I see this notation right here, that means I have the answer. I want to know what I put in. I have the range value. I want to know what I put in to get that range value or that answer. Okay? So that's what inverse means. So if I'm asked to find the sine inverse of, say, 1/2, well, where am I going to find an answer of 1/2? A positive 1/2. Where would I find an answer when I do the sine of an angle is going to give me a positive answer? So I know that potentially, if I let this equal theta, I have potentially theta could equal, in quadrant 1, that would be that'd be pi over 6. Right? Do you all agree that pi over 6 produces a positive 1/2? But without restricting our domain, which we will, we're not going to do that right now, I also know that that also would have gave me a theta of 5 pi over 6. That's another place in which my sine would have been a positive answer. If I put 5 pi over 6 in my calculator, it's also going to give me a positive answer. When I'm looking at cosine, which quadrants is cosine positive? So cosine is positive here, and cosine is positive here. What we're going to be chasing is angles that build a triangle. Does it make sense for me to have an angle that builds a triangle down in this quadrant ever? Why not? Well, first of all, if I decide that I want to go into a negative angle, so I'm going to go negative pi over 6, can I have a negative angle in a triangle? No. If I decide I'm not going to go negative, I'm going to go positive, what are those values that are in that quadrant? Well, greater than 180. So at the very least, it's going to be 270. And the very most is going to be 360, but we know that the triangle has to add up, all the angles have to add up to 180. So it makes no sense when we're doing our inverses for triangles to have anything other than in quadrant 1 for our cosine. Now when we do the inverse, we could potentially have one in here and one in here as answers when we do the inverse for a triangle. And when that happens, those are the ambiguous cases, and we're going to give you some things to look at to give you to determine whether or not you have 1, 2, or no triangles. So that's what all this is saying right here. When I do the inverse here momentarily in my calculator, now we're going to really hit what inverse is in terms of domains and ranges, but for us in triangles, if I do the inverse for cosine, I only look in quadrant 1. That gives me that answer. But for sine, I have 2 quadrants in which that's going to be a true answer. So I have to look at quadrant 1 and possibly quadrant 2. So get your calculators out. And please give me these angles. Now, when you get all down to B and you're all excited and you're thinking, wait a minute, that doesn't look like anything I've seen before, because I can put the sine inverse in my calculator. We have this rule when it comes to inverses that if I have f of f inverse of x, that had better be equal to x. Or I have f inverse of f of x, that also had better be equal to x. The reason I'm telling you all this is if you have the tangent of some angle, or sine or cosine or cotangent or whatever your trig function is equal to, say, 2.1, and if I want to chase that angle, then what I do is I'm going to take the tangent inverse of this side. I'm going to take the tangent inverse of this side. Using the rule that I just wrote in terms of f inverse of f and f of f inverse, I know that this side will become tangent, or theta, and this side becomes the tangent inverse of 2.1. And that's how you're going to do B, and that's how you're going to do D. All the rest of them, you just put those babies in your calculator and you walk away a happy person. So go ahead and do A through D. I'll give you a couple of minutes to do that. 68.42, so I'll just do 68.43, 48. So I'll just do a 3. What is it? Okay. Now, as a reference angle in quadrant 2, what is another angle that could happen? If we use that as a reference angle in quadrant 2, what is another angle that could happen? So if I'm not sure how to find reference angles, I take 180 degrees, 68.4, that's my reference angle. I want to know what angle also could produce that number. So 111.6. Put 111.6 degrees in your calculator. See if you get the 0.93. Did you? Just about, yep. No, just the sine of 111.6. Okay, so for part B, what did you all get for part B? Raise your hand if you can give me what you got for part B. Yes.
36.87 degrees.
And what else did you get? Fair enough.
143.13 degrees.
How was that? You all get the same similar numbers? Raise your hand if you can give me the cosine inverse of 0.368. 0.368. Devin, you got one? 68.41. Now, do I have to worry about putting that in quadrant 4? That makes no sense to put it in quadrant 4. All right? Sines I do. Cosines I don't. Did anyone get you all got 68.41? Okay, cool. Cosine theta is equal to 0.5. What'd you all get? Again, does it make any sense to go into another quadrant? Nope. How are we doing so far? Cool. So, oblique triangles. Oblique triangles are any triangle that does not have a 90 degrees.
Are you doing more than just that?
Yes. And I have my microphone on this time too. Oblique triangles are any triangle that does not have a 90-degree angle. We are mostly chasing obliques. Now the notation part, how you label it, is not important except for the fact that this must happen. Alpha and side A must be opposite each other. Beta and sine B must be opposite each other. C and gamma must be opposite each other. So when you set these up, those are important. Where you put the sides does not matter. If I wanted to build my triangle and I decided that I like to have A right here, cool. That means alpha has to be opposite it. If I decide that I like B here, cool. I better make sure I put beta there. That gives me only one choice for C. That means gamma has to be there. How you label it in order does not matter as long as your angles and sides are opposite each other. And I cannot emphasize that I need to emphasize that like 100 million times, because if you don't get the right answers because you didn't put your alphas and your A's opposite, your betas and your B's opposite, and your gammas and your C's opposite. Those have to be opposite each other. When you are looking at your triangles, and the way it is wrote is how you are going to write it. So the first one is angle, side, angle. So if you have angle, side, angle, that means you have this angle. However you want to start it, it doesn't matter. I like to start in the bottom left. However you want to start, you can start it in the top. You are given this angle, you're given this side, and you're given that angle. This is angle, side, angle. Does that make sense? So if they give that to you, that's how you write it down. Now I'm going counterclockwise. If you want to go clockwise, it's fine. But the important thing is, it is the side between those two angles that is given to you. The other one is angle, angle, side. I'm going to go out of control this time, and I'm going to give me an angle here. And I'm going to do an angle clockwise because I'm going out of control. And then I'm given this side right here. Okay, it's important that as it is given to you, angle, angle, side, that you write it down just like that. I went clockwise this time because I'm out of control. Side, side, angle. This is the ambiguous case. So you're given this side, you're given this side, and you're given that angle. Side, side, angle. The last one, or the last two, is side, angle, side. So you're given this side, you're given this angle, and this side. Side, angle, side.
For the last two, does it matter if you go clockwise or counterclockwise?
Nope. Nope.
As long as it's in that order?
As long as it's in that order. I don't care if you go clockwise, counterclockwise, you start on the bottom left, you write your triangles upside down because you're out of control too. Do whatever you want, just make sure it is in the order in which it's given to you. Okay? And then last one is side, side, side. And that's when we do, you're given all these sides, and these sides. And we're going to do that when we do the law of cosines. So law of cosines uses that one. All right. Here's the relationship for the law of sines. This works for any triangle. Doesn't matter if it's a right triangle or a non-right triangle. This works for any triangle. Notice that we have this relationship here, that my A and alpha are related, my B and beta are related, and my gamma and C are related. Can I write this as A over the sine of alpha? Sure. B over the sine of beta? Absolutely. And C over the sine of gamma? Yes. So if I want to have my sides on the top and the numerators, I can do that. If I want to have my sides in the denominators, I can do that too. What's important, however, is that you have your A and alpha, B and beta, C and gamma together. And the other important piece is when you're doing this, it's important that you have all of your signs all either in the numerator or denominator, and then you have all of your sides either in the numerator or denominator, but it is consistent. Don't do any of these weird shenanigans. Don't shenanigate and say does the sine of alpha over A is equal to B the sine of beta. That is a shenanigation. Don't do it. It's an official word, shenanigation. So any questions? You all wrote those down, right? The relationships? Cool. Here is the ambiguous case. The ambiguous case is when you have a side-side angle. So we have something called h, that's the height of the triangle, and it doesn't matter if it is a right triangle or not. We always have a height of a triangle. And how you decide the height of the triangle doesn't really matter. Notice if you have side angle, here's the side, here's the side, and here's the angle. Those two have to be opposite each other. The height is given to you as B, the sine of alpha. Now what happens if you're not given A and B? You're given A and C. Well, it depends on what the angle you're given. So if you are given A, and you're given C, and you're given gamma, as an example, then your height would be A, the sine of gamma. Now, if the height on this one, if the height is greater than A, you can clearly see no triangle will be formed. If the height and A are the same thing, we have a right triangle and we're happy and we walk away. If the height is less than A and A is less than B, then we will have two triangles and we have to find both triangles. If A is greater than or equal to B, I don't even have to do the shenanigation of finding the H. I just know I'm going to get one triangle. If you decide I don't want to remember any of this stuff, cool, you don't have to. Because this one will always shake out when you start doing the law of sines. That one shakes out. Because when you go to do the sine inverse, you're going to get an error on your calculator. So that one will shake itself out. It always does. It's this one you have to worry about. That's the only one you really have to worry about. All the rest will shake out. And that's the ambiguous case. And I'll show you how not to worry about the H if you don't want to worry about the H. You're like, it's just too much. Cool. I'll show you how not to worry about the H.
Question.
Yes.
So are you suggesting that H is on the outside of the triangle of the building?
So H is the height, and it's never going to, well, the H could be outside the triangle if you have a triangle that looks like this. If I decide I want to say this is the H, H is always perpendicular to one of the sides. So it could be outside, and I could get a triangle. I could or could not get a triangle, depends on what the relationship is. Yes?
So if you get a situation like that, you can find both triangles come up.
There's potential for, so the question was, will I have both triangles? The only time I'm going to have both triangles is when this relationship here happens. And if you don't want to remember this, I'll show you, there'll be an example in here which I don't address that. I just say, okay, well, there's a possibility that this could happen with a second one. Does that make sense? Okay. So let's go ahead and do our triangles. The other thing that you're going to look at is if On this one, if the side, you're given angle or side angle, that if my A value, which is one of that's the side opposite the angle given to me, is less than or equal to B, there is no triangle. And then if A is greater than B, there's one triangle. And this is when my angle is in the second quadrant. So if the angle that's given to me in the second quadrant, I can have one or none. Again, you don't have to memorize this stuff because it'll all shake out. I promise you, it'll all shake out. All right. Let's take a look at C. I'm going to take a look at C, and I'm going to write all this information down on the left-hand side here. So I have 39 and 18.4 and 33.7. So the first thing I do is draw my triangle. This is, I'm going to call this 39 degrees, 39.6 degrees. That means opposite that needs to be my A, because that's alpha. So I need to put A opposite that, so I'm going to put in the 3.7. Doesn't matter where I put the 18.4. No, not at all. So I'm going to put in the 18.4 right there. When they're asking me to solve for a triangle, they're asking me to find all the missing pieces. They're asking me to find all of the other two angles, and they're asking me to find the other side. So I start out with the sine of 39.6 degrees over 3.7, because that's the relationship that's happening, is equal to the sine of gamma, because that was opposite C, over 18.4. So what I'm going to do is I'm going to go ahead and multiply both sides by 18.4. And so I'm going to have 18.4 times the sine of 39.6 divided by 3.7. Somebody tell me what you get in your calculator. Make sure you're in degrees for that. $3.17. What is the range of sine? What is the lowest value sine will ever take and the highest value sine will ever take? 1 and negative 1. So can I take the sine inverse of 3.17? No, because it's not in my range. No triangle. So notice I didn't have to worry about the H shenanigans. I just jumped right into my law of sines, and it shook itself out. Try doing the sine inverse of 3.17 on your calculator. Make sure you're in degrees. Should give you a nice I don't like you button back.
Oh, yeah.
Okay? So I stop at that point. It doesn't, and there's no triangle formed, so I'm done. Please do A, B, and D. I'll give you a couple of minutes to do those. A. Now I have to find all of the sides and all of the angles. So I have not the ambiguous case, so I don't have to worry about finding H. Don't have to take that extra step. Don't have the ambiguous case because the ambiguous case is side angle. I have angle, side, so I don't have to worry about that. What I know is all angles in a triangle add up to 180 degrees. So if I take my 180 degrees, subtract off alpha, and subtract off gamma, in this case I'm going to find my beta, because that's the one angle that's missing. So I have 180 degrees minus the 10.3 minus the 143.7 degrees. So my beta is equal to what? What is it? 26 even? So 26 degrees. Now, it doesn't matter where you start with your angles. I'm going to go crazy this time and put my alpha up here. That means my A has to be opposite it. I'm going to put my beta here, so my B has to be opposite it. I'm going to put my gamma here. That means my C, which is 48.3 centimeters, has to be opposite it. 48.3. Now I'm going to do the law of sines twice. I have to do it twice, once to find A and once to find B.
Can you change the bill?
You can, but I don't want to. The question was, can I chain them together? Yeah, but I don't want to. So I am chasing the A. Whatever I am chasing, whether it is the angle or the side, I always put it in the numerator. So I'm going to write this as A over the sine of 10.3 degrees is equal to the 48.3 centimeters over 143.7 degrees. The only reason I'm doing that is so that I don't have to do that extra step in dividing by. So I get A is equal to 48.3, the sine of 10.3 degrees, divided by 143.7 degrees, or 143, that should be the sine there. The sine of, that should be the sine there too. Let me put the sine there too. So the sine of 143.7 degrees. So somebody with a calculator, tell me what you all get for A. 14.58? Okay. This is not a right triangle. I cannot do A squared plus B squared equals C squared. This is not a right triangle. So I have to do the law of sines again. So I have B over the sine of 26 degrees is equal to the 48.3, the sine of 143.7 degrees. When you are doing the law of sines, you always want to go back to the known quantities, not the calculated quantities. So when I'm trying to find the other side, I'm going to go back to the known or given quantities, and this is going to prevent any kind of round off issues you may have. So make sure that you go back to the known or given quantities. So on this, I get B is equal to the sine of 26 degrees, 48.3, the sine of 143.7 degrees. So what do you all get B to be? $35.76. And what are my units on this? Centimeters. Do not forget your units. How was that? Was it too bad? Was it awful? Was it okay? It was cool? All right. I'm going to talk a little bit about the applications. And then tomorrow we're going to pick up the law of cosines. So the applications are bearings. There are two different kinds of bearings. Air navigation is a different kind of navigation than marine navigation and surveying. So air navigation, everything is off of the due north. So if you're doing an airplane, they're going to tell you it is 30 degrees off the north. So it's 30 degrees off the north. So when you do an airplane navigation, it's always off of the north. So if you say 30 degrees, it's off the north. If you say it's 120 degrees, it is off of the north, 120 degrees. And it is the counterclockwise and clockwise rotation. If you are doing marine navigation, you're on a boat, it is slightly different. They're going to do it in the northwest or the southwest. So they're going to give you it at 30 degrees off the north in the east direction. Or they're going to give you 70 degrees off the north in the west direction. But they're also going to give you 50 degrees off of the south in the west direction, And they're also going to give you possibly the 20 degrees off the south in the east direction. So airplane navigation is only one thing, and it's always clockwise. So if I say it's 270 degrees, there's 270 degrees clockwise off the north. Marine navigation will give you the off the north and the south in the east or the west direction. Cool, huh? I wonder what, has anyone Navy here? Because you know the Navy has both airplane and marine navigation. Just wondered how that worked out. We're going to pick these up tomorrow, but I want to go back and talk about one of these here. I'm looking for the ambiguous case. Don't pack up yet. I'm looking for the ambiguous case. The ambiguous case is the side-side angle. Which one of these could be the ambiguous case with the side-side angle? D. So let's do D really fast. So let's start out doing D. I'm going to call this 41.2, 8.1, 10.6. So I'm going to do the sine of 41.2 degrees over 8.1 is equal to the sine of beta over 10.6. So somebody with your calculator do the sine inverse of 10.6 multiplied by the sine of 41.2 divided by 8.1. Tell me what you all get. Somebody with a calculator, type it in exactly like that. Make sure your parentheses in the right places. What'd you get? 54? Do we have confirmation of a 54? Okay. So I've got my beta is equal to 59.45. 59.4 is good enough. All right. Add 59.4 to 141 and tell me what gamma could be. So 180 minus those two angles, in other words. What is it? No. Take those, add them together, and subtract it from 180. What is it? 79 point. Okay. Now, what I want you to do is I want you to take 180 minus the 59.4 in and of itself only. Tell me what you get. What is it? I want you to take the 120.6. I want you to add on that first angle, which was the 41.2. Is that number larger than 180? You have two triangles. The second triangle is 180 minus that number. So take 180 minus the 161. So your other one is 18.2 degrees. You have two triangles. Notice I didn't have to do the H to tell me there was two triangles. If I lost you, watch the video, at least this part of it. Have a great day.